Welcome back to Made Up of Wires. We have false starts quite a bit, but we'll get going. We're decompiling Castlevania Symphony of the Night, and you can go to soten.z.dev to learn more. We're not dropping frames this week. Called the Coxman out. And they replaced not one, but 4 connectors on various fiber lines. I don't know what they could be doing where a connector on the fiber just stops working, but hey, I didn't install it. I did help, but I didn't install it. Alright. Today's going to be a short stream. Go to soten.z.dev to learn more about the Symphony of the Night decompilation project. We're working on NZ1, which is the clock tower. And let's get into it. Let's see what there is and see what's left. So we're looking for any include ASM lines. We want to replace those with C code. I don't know what the 0 option does to graph it. Looked like it was putting 0 lines of context before and after. That's kind of interesting. Let's see. Entity water foreground, I think, is a duplicate. Water effects may not be duplicates. We could look at those a bit. I don't have a significant amount of time to spend, so anything fast would be nice. Entity cloud's probably a duplicate. Let's look at some of these water effects and see what's there. We could get a couple of them done, maybe just one, we'll see. We're going to look at the dupes report. And see what is here for water drop first. We should have, I would think, a lot of these. Yes. Small water drop. Yes. And let's look at, so all of these are here. I'm not going to do if it's all duplicates, I'm not going to worry about that. Somebody else can come in and clean up the duplicates. Or maybe I'll do it later off stream. Not terribly important to do on stream since we've done lots of duplicates and I've showed how those go in the past. Skull Lord, that should be common. Have we done all the interesting things? Maybe we need to do something else. Let's look at clouds. I would think clouds is the same as Castle Keep. They are not. So we do have a unique cloud. So let's look at the clouds. Typically, I don't remember what the clouds look like in Clock Tower. We can fire up Duck Station and see. Project Oblivion wrote a comment. These entities, or the entity clouds, is quite a bit different from the DAI and RBO3 cloud entities. RBO3 is kind of an odd choice, but RBO3 is the Richter boss fight, I believe. No, it wouldn't be Richter. RBO3. Let's look at where RBO3 is. The Medusa boss fight in the chapel, DAI RBO3. We would also have top and RTOP clouds, and it doesn't seem to match those either. So we do have a new cloud type. We're going to grab that. And is this long or short? It's kind of in the middle. Let me see if I can get Duck Station going, and if I'm anywhere close to outside. I have to go through the clock tower to get back outside, but it might be worth looking. So let me try to grab that. And let's see if this controller is going to work. It is connected, but it never seems to want to actually get set up the first time. So we'll just do it. I was playing, I play Overwatch with my sons, and we were playing the other day. I typically play support or damage. I actually like tank quite a bit, but it's a lot of pressure, and I play to relax. Is that going to work now? No. Let me quit Duck Station and restart it. I didn't have the controller on when I started it, so that might have been the issue. Remind me later. Yeah, there we go. So anyway, if you're familiar with the game, there's a character called Lifeweaver that I play. That's probably my third support. Zenyatta main. And we're in the middle of, I think right at the end. I don't have any health. I did leave this. Nothing to deal with either. Oh, this is not going to go well. Yep. Let's see if I can. I might have to go back a little further. Or just get good. Anyway, so we're playing, and it's the end of. It's a map where each team takes turns as offense trying to get the objective. And it's right at the end. Okay, so here's the clouds. They're wispy, and there's kind of a 3D what's the right word? Warp or deformation that's happening. So there's probably going to be some. Oh, and there's our flail guard from last week. Anyway, so with Lifeweaver, you hold R2 to heal and then let go. And then you use L2 to fire an offensive weapon. We're going to decomp.me to do this. And usually I'll be holding heal, waiting to use that ability. And then switch over real fast. And L2 did nothing. And fortunately, we won the round, started the next one, and, oh, come on, decomp.me. When I said my internet was fixed, I meant maybe. Well, this might be a short stream anyway. Yeah, anyway. I started the next round, and L2 worked again. But then as the match progressed, L2 stopped working, and I had to go that controller, get a new one, and it was the controller, and I was shocked. I don't think I ever had a PlayStation 4 controller die on me. So I have a controller die. It seems like Safari is failing. So yeah, getting a... Let's see if I can find these processes. Having a controller die in the middle of an online game is rough. There we go. Sometimes Safari networking dies, and that seems to be the case. We'll create a new one. Well, so now I need to decide whether or not I'm going to try to fix this controller or not think about it and just get a new one. All right, so what do we have? We have something around line 95 where we're not able to tell what it is. Var S4. Oh, I'm not getting search here, so it's not ideal, but we'll save this and we'll try to figure out what it is. Var S4 is at sign 16. Var S1. I would assume that this is a primitive, but it's a scratch space. We don't know what it is. There's a couple things we can do. We can try to build up this struct manually. That's probably the best option. So we do have a general idea of where all the fields are, and that's something we'll have to do. So let's fix the signature here, and then we'll start building that struct. Unlike most programming we do on things with full operating systems, we normally don't think of accessing cache directly. That's something that's usually, but not always, something lower level libraries do. And the PlayStation's a little different. Embedded systems in general are a little different. Here we have an address that specifically is something we call the scratch pad. And we could, I don't think there's any reason not to put a symbol here. And that might not be the worst idea, actually. And just call this address scratch pad. Most of the addresses we have start with an 8. This one starts with a 1. The top 2 bits of the address tell the memory interface how to access that data. They are flagged, so there's only 22 bits of actual address space that's available. And where'd arg0 go? Line 19. Why do I have an arg0? All right, so let's... Oh, this is rough. I'm gonna try reloading this page and see if I can get this to work better. Is this capturing? No, it's still not capturing keys. Ugh. Okay, so we'll get through this. Not the end of the world, just... not ideal. Basically, I can't copy and paste, or can't use keys to copy the whole thing. We're back on entity flail guard somehow. We don't want to save that. Let's get back to where we were. It's one of those days. You ever have those days where you're working hard but can't seem to make progress? That's the kind of day it is for me. All right, so we're going to make a struct. We'll call this cloud cache. And as we go through, everything that is happening to this var S6, which we can't search for, basically all of these offsets, we need to figure out what those are and how they're going to be accessed. So we know that offset 0, offset 2, those look like sign 16s or 16s. We don't know yet. So we'll call that unknown 0. We'll make another one, unknown 2. And then we'll go to var S6, and we'll make this a cloud cache pointer. And now unknown 0 and unknown 2 will start becoming something. Looks like on 126 we have a different variable that's being used. So we'll have to do that there as well. Var A0 underscore 2. No, it thinks it's a primitive. Var V1. That's more like it. But this will also help us identify what these are. And so as we fill these out, 100, there's another one. Var S1. Guessing var S6 underscore 2 is one of these as well. We can't search for it. We'll figure it out. Var S6 underscore 2. Yeah, it is that as well. And so is there a high likelihood that this is just a sign 16 array being treated that way? Yeah. There is some merit to that. There's a couple more in here. We'll come back and get to those. But what we know is that we have up through, I'm just going to keep making these sign 16s, going up by 2 each time. So 4, 6, 8, A. That'll get us to A. We have a C. And then we have pretty high. We have at least 16 of these. So we'll go up through 20 or offset 32. And we're going to put these in hex notation to map how we get the errors. Did I miss one? I did. Thinking powers of 2. So now what we're left with is just some errors related to probably incorrect use of variables of that type. So this we need to call a cloud cache. 133, probably the same thing. Var S6, this is going to be pointed to unknown 0. This is S16 max. still can't search here, so can't find that, but my guess is that it's going to be S16 match. RS6 underscore 2. Yeah. Same thing here. Let's change that to unknown 0. Then 155 is our last one. We should be compiling, and same thing there. And so are these an array, or is it just an array of 16 byte stuff? Maybe. And we're at 82%. It happens both ways. So the scratch space is kind of a fast memory that's on the CPU. I don't have a good sense for when it's used versus not, or if there's some advantage to it with the SDK, like storing things there in the SDK when you are using other SDK functions. So I'm going to go through, try to clean up variables. Ooh, that's rough. I don't have we're just going to have to use compiler errors. I don't have a way to search and replace right now. So all the A0s we're going to change to prim. I can... use some navigation keys. That is working. We're just gonna have to keep going, find all these. While I'm here, this is gonna be while prim is not null. We can get rid of the do while. Oh, drat. Oh, drat. This is gonna suck. This is gonna suck. So I hit a navigation key to jump to the beginning of the line. That's normally captured by decomp.me, but it's not right now because none of my keys are being captured properly. So it made me go back instead, which undid all the renaming that I just did. Lovely. I'm living dangerously. I don't know why this happens sometimes. Like I said, just one of those days. Hey, Dizek, good to have you back. Spent far too long this morning looking for sleeping bags. And this is where I can't undo the hotkey for, or the key combination for decreasing is command bracket. That'll decrease the indent. I wonder if command shift will. Yeah, that does it as well. But that will go backwards in the browser right now. So we do have an entity extension of our A0. I still need to fix some of those. And 68. All right, so we have that. And then there's another one. I'm gonna get rid of this var A0 underscore 2, and we'll do all of that again. And so I'm a little hesitant to name these fields for the cache right now. And the reason is I don't know yet if this is actually going to be a real struct or if it's going to be something else. It's possible that it is just an array. If it's just an array, then I want to be able to quickly go back and turn it into an array. 153. And I think that's the same thing. I think this is wild. Odd construction here. But I think that's just the optimizer being silly. I think we can break there. Yes, that outer one is a for loop. I don't have. I'm not in a good spot with navigation or find and replace. So I'm being somewhat selective with how I'm going about this at the moment. So we do have a bunch of these variables that are doing. Let me save this. I'm gonna try refreshing this page one more time and see if that gives me back my keyboard navigation. Yes, there we go. Okay, we're back. We're so back. I'm going to get rid of all these different, I called it cache, but it's really scratch space. I'm going to get rid of all of those and replace them with just one. We'll call it cloud scratch. And okay, so this makes me think that maybe there is something to this being an array and not a struct, which is kind of a bummer. If that's the case, then it just limits what we can do. I like the idea that I would be able to name these their appropriate field names, but if we're doing something strange here, we're not. So that one seems like it's fine. Let's, as Dizik said, let's turn this into an I. And then fix this loop. Interesting. So there actually is an outer loop as well. Let me undo that. Make sure that I'm... So this while loop replaces this. Then we can get rid of this here, and get rid of our extra plus equals I. And so what I'm looking for is, when are we mutating unknown 0? Is it possible that there is... How is this not a infinite loop? It's possible that something else is also, since this is a global scratch space, it is possible that something else is modifying this. Or M2C didn't get it quite right, and so we're not in a big while loop. But what it looks like is we're until this condition is met, we're going to keep modifying these early primitives. All of this blocks, and we're setting that scratch space value to this right away. So unless there's some other external process that can change that scratch space, which I'm not familiar enough, I guess, with the PlayStation architecture to know if that's possible. But this should never... all this code should just go away. The compiler can't know that because this address is written in a way that the values shouldn't be cached. So I think we'll come back to that and see. So while we're doing that, let's look at this guy here. This looks like an I as well. No, it may turn out to be I, but it's something a little different. As far as 0, though, does look like an I. GCC does this sometimes, where it will invert the condition. So even though it's 0 to 4, it'll change it to 4 to 0. And if nothing's reading it, it doesn't really matter. The pointer is changed after assigning to unknown 0. In this case, it is. But down here, it's not. I'm going to do some other cleanup here. Hey, OTM. So here virus 0 is also being used kind of like an I. It's effectively a mod of the bottom 2 bits. But it's not being used anywhere. Oh, it's being used for temp v0. I see, it's being used way down here. Let's replace these. And so I think I'd rather write this as something like var S0 plus 1 and 3, but it could be mod 4. Let's try that and see. Could it be a plus plus and then a mod equals 4? And then we can get rid of temp S0. This debug logic at the end, I can go grab that. That's normally just imported. Add to animation debug. And so we'll throw that down here. We don't have to rewrite it. Let's see how our top is looking. Top is looking pretty good, except for an and on 68, which is this area that we were looking at before. Let's do this then. Let's move the var S0 up here, and we'll do I would need a second variable. I'm going to leave it for now. We'll debug with the PSP. We do need an entity extension, so let's start that. I'm going to do what I have been doing. It's worked out pretty well. We can try using any existing clouds that might be there. Let's see if there's a clouds. These look a little bit different, but we'll see if it ends up being materially different. It'd be nice if it does reuse the same struct. So we have a prim at offset 7C, which would be 0, so that's not there. And then a bunch of unknown stuff. So missing 4 bytes. So basically we're 8 bytes in at this point. And nothing. And everything is 32 bits after that. So it's a new type that we haven't seen before. And these do look different, so that makes sense. So what offsets do we need? 3, 4, and 5 are definitely there. Look for all the illegals. We have 1, 3, 4, 5. It's always odd when these structures are only used in one function. And they don't pack these addresses right at the start. I never understand why that might be. So we're going to call this unknown 7E. Let's actually get a... We're going to put this earlier than illegal. We'll try to get a decomp that favors that. Still nothing. Why that's not matching. Oh, it is matching. It's just the only place that it's used. Again, strange, because I don't think anything else uses this struct. Now let's take out the... not quite yet. Let's put a few more in, and then we'll do that. So we have another sign 16 pad. So next is offset 3 at offset at 82. See if this starts getting picked up yet. Yeah, we're starting to get some of them. Okay, we'll do 86 and 88, and I think that's enough. So we have 0, 1, 2, 3, 4, 5. I think there's only up to 5. And we should get the, yeah, all the correct offsets here now. We're just going to grab those. Their M2C thinks that they are unsigned. Could be. And it could be that that's just what M2C defaults to. I don't see a reason not to just reuse var S5 here. Let's see what my error is. No, Symphony. We're getting a little further away. That's fine. I'm not terribly concerned yet. We can see what right now we can still see what our unknown offset is supposed to be here. Whether or not these are variables or they're just being cached, we don't know. This kind of looks like an angle. It is, yeah, let's call it angle RS7. And it is being preserved, so we do need to keep track of it. Temp v1 underscore 4 is also the current angle value by this point. So there should be a plus equals. And I think we can get rid of that var then. And if angle isn't already a sine 16, it should be. And our shift over by 12 is the fix to I macro, getting the integer portion of this PlayStation format fixed number. Var fp and we're doing the same thing here, so I am gonna, I guess we'll use the fix to I macro down here. It's a little strange to have it separated like this. There is this multiplication that's happening up here. The while can move up. It's possible that it's a for loop, but we'll see. Not super happy with how this is going. And what did I screw up? 105. Go grab the PSP version. Actually, I'm going to have to call it a day soon. It's late, but I don't necessarily think that the PSP is going to be any easier. But there's a few things around the structs that may be a little more straightforward. I'm going to grab this one. And we need to get the context as well and update the primitives. We'll just see where we are on the PSP. Uh, 53%, obviously not stellar. Let's look at some of the things that M2C might show us. So I'll throw init environment and pads pressed into the context to get a slightly better. So our initialized entity, all that, there's some ordering, but other than that, it looks pretty good. Ordering down here too. Prim index. I'm okay with all that so far. And then our while loop. And the while loop is looks mostly the same. So this is var s0, and then at the top var s0 and equals 3. I think most of the time we use mod there, but they're not doing that. The shift by 5 is happening twice. So I think that this is fine if we go over and look at around line 68. There's a few things a little bit earlier. It's not obvious to me. Oh, yeah, it's probably just register related at the moment. So I'm not going to put too much weight into exact instruction differences yet, because anytime you see the SP register, that's the stack pointer, and that means we're not using registers anymore. We're using the stack. So we have too many variables, basically. Yeah, the internet is doing better. They, the Coxman came and replaced a significant number of connectors on various fiber optic cables inside and outside the house. How fiber optic cables self-degrade, I don't know. Apparently they do. What I want to look at is, so the way that the scratch pad works is a little different too. I'm going to have to put a conditional macro for that. So we have a fixed address for it. And again, I don't know why we don't have a symbol for the scratch pad. We might as well. It's at a different location for the PSP versus the PlayStation. And so we'll have to do that. This, the way that this is set up here makes me think that this is being accessed as a signed16 array. And that is kind of a bummer. So I think what I'm going to do is change var v1 to a signed16 array, and then we'll see if those instructions look more that's not what I want. More like what is in the original. I can just, I won't do it, but var v1 would be fine to use. I have to divide each of these by 2, so 14 is 20, so that's offset 10. 16 is 22, offset 11. 5. 6. 1e 28 14. And 32 is 16. And what do these end up looking like? Any better? No, surprisingly not. Well, that's too bad. So we're adding 1, shifting by 1, so that's the multiply by 2, and then adding again. So I think we try doing this another way. I think we're doing I and then I plus 1. Maybe an I times. So that looks more like it, but it's not going to be I, so we have to, there's a multiplier somewhere in here, and we're going to have to figure out what that multiplier is. So we're looking at we're adding S2. And so somewhere S2 is going to be I see. So what are we doing? This is our scratch space here. Go to, what does M2C think this is happening here? It's a multiply by 2, so these are pairs. And bar S2 is just our starting scratch pad. Okay, so it is I. But then we're further dereferencing these. Ah, that's weird. And this is a little strange. I'm going to come back to this tomorrow. Maybe work it out. Anytime you get into the scratch pad, how it is set up is a little bizarre. So it seems like there might be something a little more going on. The multiply by 2, the index here, like I'm not sure how that math is working out. My brain is not following at the moment. But so I think if I was going to write in C, we can kind of cast anything to whatever shape we want. And so to me, it would make sense to make a nice struct to represent whatever you're doing in the scratch pad. That's not always what happened, though. And a lot of times they just have signed 16 arrays and they're getting around them in strange ways. So yeah, we can try to work through some of these. So this looks like I. This one is I plus 1, possibly. This one is I. But then it almost seems like it's taking the reference to this and dereferencing it again. We could go over and look at what instructions we're generating and see if that's close. And unfortunately, that is close. 20, offset 10. So why would you take a reference to this and then go that many more in? So it could be, let's try another way to do this. So here we're going to access offset 0. But again, why are we doing this with I? Because we're only incrementing I by 1. And is this... Yeah, this doesn't quite work. So in some cases we have I plus 1 versus just I. It's slightly better, but let's go through and see if that's starting to make sense. Oddly, it is. Yeah, it's making too much sense. That is gross. I can't imagine that this is actually the notation that would be used. It does generate the correct instructions, but I mean, it's a burn it with fire type. And so each time this comes around, basically the scratch pad pointer is looks like it's loaded again. So the load that we have up here, I don't know. Not happy with that. Yes, and what we could do is let's try inverting those. Would I be happier if those were inverted? Maybe. So if we did this as 0i and 0i plus 1, is this going to generate the correct? My guess is it won't. $124. If it does, great. I'm happier with that syntax. Yeah, that does look fine. So yeah, pairs. Okay, I would be happy with that. Let's rewrite them all like that and see. Unfortunately, I mean, it's just such an odd idea. This is supposed to be 14. Because we are treating it as a like where is the offset? So we are going 0 through 4. So do we have a bunch of, and maybe that's what it is. Maybe it's a bunch of small arrays. The layout is bizarre, but I guess that makes sense. If they're all 4 size 16 arrays, we would have 5. If they're all arrays of size 5, but then why does this one start at? No, it doesn't start at 14. It starts at 15. Okay, I'm feeling a little bit better about that. So we have pairs every 5 bytes, but 5 bytes is, no, 10 bytes every 10 bytes. Still odd. So we could build our struct like that, where we have 5 sets of pairs for each of these offsets, x0, x1, y0, y1. That may make sense. The I and I+1 does suggest, though, that it is being accessed as an array as opposed to like a pair struct. But it's not as bad this way. So I think we'll get back and try that tomorrow. That's getting us a little closer. Let's see what the PlayStation thinks of that, and then I'll sign off. PlayStation likes it. Yeah, all this, except for the register on 122, everything else looks good. So my guess is that if I made this a struct and these offsets were fixed at these locations, that would be fine. So maybe we'll do that. So time to sign off. If you're watching Made Up of Wires, go to something.z.dev. Thanks everybody for joining, and I appreciate it. Adios.